This is Mr. Alexander, and today I'm talking to you about finding the equation of tangent lines and normals from a curve. This is a four-step procedure. The first step is always, if we're finding the tangent to this equation, y equals 3x squared minus 10 at the point 1, negative 7, the first step is always write down that point. So the point is 1, negative 7. The second step is going to be to find the gradient function, which is dy dx. The first derivative of y equals 3x squared minus 10. 2 times 3 is 6x. 2 minus 1 is 1. And negative 10, that's a constant that goes away. So the function, the gradient function, is 6x. What I need to define an equation of a line, the tangent is a straight line. What I need to define that line is I need an x value, a y value, and a gradient. What I'm missing is the gradient. But I have the gradient function. So I know that at x equals 1, the gradient is just 6 times 1, or 6. Now, using that information, I can write the equation of the line. Y equals mx plus c. That's the form they want it in. Let's plug in what we've got. We've got a y. We've got a negative 7. We've got an m, which is the gradient we just got at that point, is 6. We've got an x, which is a 1. And we're going to want to solve for c. So this is negative 7 equals 6 plus c. So c must be negative 13. Now I've got enough information to write the entire equation, which is simply y equals 6x minus 13. Now what I always like to do, to double check my work, is I go to the equation on my calculator, I graph the equation that was given to me, which was 3x squared minus 10. I graph the tangent line, 6x minus 13, and then I'm looking right around x equals 1, and I just want to make sure that that actually looks like a tangent line at x equals 1. I'm going to have to adjust my window so that you can actually see it. Let's go from negative 10 to 10. And it looks like, here's my quadratic, it's my original function, and there's my tangent line. You can see that it just barely grazes the quadratic right there. And that's what a tangent line is supposed to do. It's supposed to only touch that curve at one point, which is exactly what's going on there. So I'm feeling good about that answer, 6x minus 13. Talk about tangents and normals. So let me show you one about normals here. And the process for finding the normal is exactly the same as a tangent, except now we are going to use the perpendicular gradient. So if I could draw you a rough picture, actually I could just use this one I've already got here. Here's that quadratic, here's the tangent line. The normal is the perpendicular line that goes right through that point. So it's the same as the tangent line, just with perpendicular slope. It goes through the same point, it's just perpendicular to the tangent line. So that's what a normal is. So here, the process is exactly the same. I've got my point, I've got my function, I need a gradient at that point. So I'm going to go straight to the gradient function. But before I do, I'm seeing I've got this weird thing right here, 9 over 2x. Another way to write that is y equals 5x minus 9 over 2 x to the negative 1. Now I happen to not like fractions when I can avoid them, so I'm actually going to rewrite that as negative 4.5 x to the negative 1. I just think that's a little bit easier. So the gradient function then, 1 times 5 is 5, x to the 0th power, that's all going to drop out. Negative 1 times negative 4.5 is positive 4.5, x to the negative 2nd power. I like to rewrite that as 5 plus 4.5 over x squared. So I've got a gradient function, but I need a gradient at the value of x that's given to me. So I need to find at x equals 3, what's that gradient going to be? Well, dy dx equals 5 plus 4.5 over 3 squared. 3 squared is just 9. 4.5 divided by 9 is 1/2. So this is 5.5 is the gradient at that equation, at that point. But because I'm looking for the normal, I don't want this gradient. I want the perpendicular gradient, which is the negative reciprocal of this. It's a lot easier to find the negative reciprocal if you go ahead and make that a fraction. 5.5 is just 11 over 2. So I'm ready to write the equation now. I've got y equals mx plus c. I've got a y, it's 13.5. I've got an m, it's the negative reciprocal of this since I'm looking for the normal, negative 2 over 11. I've got an x, which is 3, and I've got a plus c. Negative 2 over 11 times 3 is negative 6 over 11. So I need to add 13.5 plus 6 over 11. And that comes out to be some awful number which gets down to 309 over 22. That's my value of c. So to write the equation then, it's going to be y equals negative 2 over 11 x plus 309 over 22. But what the instructions specified that we need to write it as ax plus by plus c equals 0, meaning it's all on the left side and they're all integers. So I'm bringing this all over. I've got 2 over 11x plus y minus 309 over 22 equals 0. And I need to multiply all of these numbers by a number that will clear the fraction. And in this case, between 11 and 22, I'm going to multiply everything by 22 to clear the fraction. So 2 over 11 times 22 is 4x plus 22y minus 309 equals 0. And that's just about as bad as it could possibly be, but that's the equation. I'll probably do another one of those if I have a chance, something that's not quite as ugly. Let's talk about an actual IB problem, though. And this is an IB problem you might see if you look at previous exams. Consider the function f of x equals ax squared plus c. Find f prime of x. Well, that's easy. F prime of x, just the first derivative, so that's 2 times a is 2a, x to the first power. C is a constant, so it drops out. Point A is negative 2 comma 5, and it lies on the graph of y equals f of x. The gradient of the tangent to this graph, A, is 6. Find the value of A. So what's given? We've got a gradient, and we've got a value of x, and we've got a value of y. And I'm supposed to find this value of A right here. I can do that by plugging the gradient into the gradient function, or I should say substituting in where the gradient is. Negative 6 equals 2 times a, and then I'm going to plug in the x that I've got of negative 2. So that means 2 times negative 2 is negative 4, and to get the a by itself, it should just be negative 6 divided by negative 4, which is 1.5. To find the value of c, then, I now know that f of x equals 1.5 x squared plus c. And if I plug in the value of x and y that I know, 5 equals 1.5 times negative 2 squared plus c, then I can solve for c. So negative 2 squared is 4 times 1.5 is 6. So I've got 5 equals 6 plus c. C must equal negative 1. Alright, I've got time, so I want to do this one right here. where I'm finding the equation of the normal to the curve of y equals x plus 6 over x at the point where x equals 4. Okay, well, I know that the point is 4, but I don't know the y. So the y is going to be 4 plus 6 over 4. 6 over 4 is 1.5, so 4 plus 1.5 is 5.5. And I also know that the equation is y equals x plus 6 over x, which I always rewrite as x plus 6 times x to the negative first power. So from that, I can find the first derivative, y prime, which is just 1 times 1 is 1 times x to the 0th power, minus 6 x to the negative 2. And I always rewrite that as 1 minus 6 over x squared. So I've got a point. To write an equation, I need a point and a gradient. So I say, okay, at the value of x equals 4, then y prime is going to be 1 minus 6 over 4 squared. So that's 6 over 16, just 3 over 8. 1 minus 3 over 8 is 5 over 8. So that's the gradient at the point x equals 4. So I've got my point, I've got my gradient, but I'm looking for the normal. So I'm not going to use this gradient. I'm going to use the perpendicular gradient. So when I come over here and I write, all right, y equals mx plus c, and I plug in the y that I have, which is 5.5. The m that I'm going to plug in isn't this 5 over 8, it's the negative reciprocal of that, negative 8 over 5. The x that I have is 4. And I'm going to solve for c. So negative 8 over 5 times 4, that's going to be, let's see, negative 8 over 5 times 4, that's negative 32 over 5. So I need to do 5.5 plus 32 over 5. That's just about 11.9 equals c. I'm going to write that as a fraction, though. 119 over 10. So when I write my equation, it's going to be y equals negative 8 over 5 x plus 119 over 10. And if you don't like fractions, then you could write y equals negative 1.6 x plus 11.9. Both of those are acceptable answers. And just so you believe me that that's the normal, I'm going to go ahead and I'm going to graph this thing. This will be the last thing I do here. So when I type in the equation x plus 6 over x, I should probably do that in fractions. And then I do this normal, negative 1.6x plus 11.9. I'm looking at where x equals 4, so I'm just going to change my window so I'm only really looking at x equals 4. It's right about there. Well, let's change it a little bit so you can actually see it. Hopefully you can see that the line that's coming through here is perpendicular to the tangent line that would be right there. And that would create a 90-degree angle right there. Alright, that's all I have time for. Thank you for watching my video on the equations for tangent lines and normals. We'll see you next time when we're talking about local minimums and local maximums.